Assalamualaikum and hello everyone. Okay, today I will share with you the tutorial on one of the uni processes scheduling, which is round robin. Okay, as we know, there are a few uni processes schedulings such as first in first out (FIFO), the shortest remaining time (SRT), shortest process next (SPN), and this is round robin. Okay, for this tutorial, okay, I will show you the round robin where the quantum or time slice is 1. Okay, and quantum time slice is 1. Okay, the question here, okay, I take from the William Stalling slides, our lecture note. Okay, our lecture note from uni processor scheduling slide note. Alright, as we know, we have 5 processes A, B, C, D, E, and the arrival times is 0, 2, 4, 6, 8, meaning that process A arrived at 0 time and the service time for process A to finish is 3. Okay, process B to arrival time at 2, and it requires 6 service time, and so on. Okay, so actually to understand how round robin works, okay, I come up with a simple algorithm here, as you can see. Okay, try to highlight this with different color. Okay, this round robin algorithm. Okay, okay. I will explain this later, but first we need to understand how this works. Okay, to start counting or getting the finish time, okay, finish time for all the services, we first need to calculate the service time. Okay, the total service time. So if you calculate the total service time here, you will get 20. Okay, 3 plus 6 plus 4 plus 5 plus 2 equals to 20. Alright, so what we will do first, we draw a timeline here, okay, starting with 1 until 20. Okay, so that's the first thing. Okay, for round robin quantum 1, okay, so round robin we need a queue. Okay, I try to separate here. Okay, queue. Okay, this is special. Okay, and it's different from other schedulings. Okay, I will explain the algorithm here. Okay, so how to do the round robin? First, we will check the T or the time. Okay, the time slot. Okay, even though we have 20 service time, okay, meaning that for the first slot, this is where T or time, okay, the time equals to 0. Okay, and this is where time equals to 1. Okay, this is just a slot. Okay, 1, 2, 3, 4, 5 until 20 is just a slot, but the time slot is actually, okay, is 0. The time here is 0. Okay, time equals to 1, time equals to 2, and so on. So the final one will be time equals to 19. Okay, so I think I explain first. We will check the time to see whether a process arrives or not. So if the process arrives, then it will enter the queue. Okay, enter first the queue, don't execute it. Okay, enter first the queue. So, and then we need to see whether the process that just executed before has remainder. If it has remainder, then we need to enter the queue. After that, we execute the next process in queue. Okay, so we shall start. All right, so if we can see here at time equals to 0. Okay, time equals to 0, which process arrives? Okay, time equals to 0, A arrives. So A arrives, first thing we put it in the queue. Okay, and then we see the second row here, whether the process that just executed has remainder. Okay, we haven't executed any process, so we can skip this. Okay, so next, go to the next okay, row, execute the next process in queue. Okay, execute first this the process. So we'll execute A. Okay, so we write A. Okay, next we look at the this will be loop. Okay, the algorithm is looping lah. So after execute, then again we check the time and then check for the process whether have remainder or not, and then we execute the next process and so on. Okay, so we already execute A. So next we check the time. Okay, when t equals to 1, okay, are there any process arrive? No. Okay, only A. So again we check the second rule. The process just now, okay, executed is process A. So does it has remainder? Yes, A has another 2. Okay, A has remainder. So if have remainder, enter Q, put it in Q. Alright. So next, execute next process in Q. Okay, execute A. Okay. So next, t equals to 2. Okay, at t equals to 2, are there any process arrive? Okay, 2, B has arrived. So if B has arrived, B enter Q. So the process executed just now, okay, does it have any more remainder? Yes, another one. So put it in Q. Okay, next, execute the next process in Q, execute B. Alright, so we check, this is t equals to 3, okay? I don't have to write everything here, we just know t equals to 3. So t equals to 3, there's no process, no other process, alright? Okay, so B, the one that is executed just now, does it have any remainder? Yes, B has another 5 service time, so put in Q. So, and then execute the next process in Q. Execute A. Okay, so this is where t equals to 4. So at t equals to 4, C has arrived. Okay, so C has arrived, C put in Q. So A executed just now, does it has any more remainder? No, A already finished. Okay, so next, execute the process in Q, B. Okay, again, check t equals to 5. So at t equals to 5, okay, still no new process, alright. See, continue. We check whether whether B has any remainder or not. Yes, okay, B has 4 more service time and put it in Q. Alright, and then execute the next process. Okay, execute C. So now t equals to 6. So t equals 6 equals to 6. Okay, t equals to 6, D has arrived. So D has arrived, put it in Q. And then C, the one that is executed just now, okay, does it have any remainder? Yes. Okay, C has another 3 service time, so put it in Q. Okay, next. Execute the next process in Q. Okay, execute the next process. B. So this is t equals to 7. Okay, t equals to 7. No new process. So we shall continue. Okay, we check whether B has any remainder or not. Okay, B has remainder 3. Put it in Q. Okay, and then execute the next process. Okay, execute next process D. Okay, now this is t equals to 8. So t equals to 8. You can see E already arrived. Okay, E already arrived at t equals to 8. So we put E in Q. Okay, the D that is executed just now. Okay, does it have any remainder? Yes, another 4. So we put D in Q. Okay, then execute next process in Q, execute C. Okay, at this time, at this phase, all the processes have already arrived. Okay, so we don't have to check the T. Okay, we can skip this checking the time slot because all processes already arrived. Okay, by this stage, no more new process. Okay, the one that executed just now, C, does it have any remainder? Yes. So put it in Q. Okay, next, execute B. Okay, B, does it has any remainder? Yes. B has remainder, B put in Q. Next, execute E. E has any remainder? Yes. Another one, put it in Q. Okay, next, run D. Okay, D has any remainder? Yes. Put it in Q. Okay, next, execute C. Okay, does C has any remainder? Yes, one more. So this time, we put C in the queue. Okay, next, we run B. Any more remainder for B? Yes, another one. So put it in Q. And then next, run E. Okay, E already finished. So finish, we don't have to put in Q. Continue with executing the next process, which is D. Okay, we run D, check whether D has remaining or not. Yes, another 2, so put it in Q. So next, we run C. C. C, any remaining service time? No more. So C already finished. Okay, next we run B. Okay, we run B. So B, any more remaining service time? No more. So B already finished. And then finally we run D. Okay, so D, another one. Okay, remaining. So put it in Q. And then finally run the last service time for D. Okay, so this is how round robin works. Okay, so you can cross check the answer, okay, with the one in the lecture note, okay, the slide note. Okay, you will get the same answer. So after you have the finish time, okay, so you can calculate, right? Calculate to get the the round robin, sorry, the turnaround time, the turnaround time. Okay, so we know the formula, okay, to get the turnaround time. Okay, I put it as TR. Okay, turnaround time equals to finish time minus arrival time. Okay, right, this is the formula for turnaround time. We get the turnaround time. Okay, so we can list all of this again. Okay. Okay. I'll list it as like this: A, B, C, D, E. Okay, so the arrival time. Okay, I simply put it as T. Okay, T A. Service time is T S. Okay, so this is T A, T S. The arrival time 02468. Service time 36452. Alright. Okay. So basically, we already get the finish time by doing this. Okay, timeline. Okay, so the finish time for A is 4. Okay, 4. finish time for B is 18. Finish time for C is 17. Okay, finish time for D is 20. And finish time for E is 15. Okay, so to get the turnaround time, okay, finish time minus arrival time. So 4 minus 0 is 4. 18 minus 2, you get 16. 17 minus 4, you get 13. 20 minus 6, 14. 15 minus 8, 7. Right? So we already get the turnaround time. So if you are required to get the average, okay, for example, average turnaround time, then you have to sum out all these turnaround time, 4 plus 6 plus 13 plus 14 plus 7. Okay, get the summarization of this, and then divide by how many process. Okay, for example, so average of turnaround time, sometimes known as mean. Okay, the mean for turnaround time. So 4 plus 16 plus 13 plus 14 plus 7, then you divide by the number of process, 5. Okay, so you shall get the answer, the mean time. Okay, the average of turnaround time or the mean time. Okay. Okay, this is how you calculate the round robin uniprocessor scheduling.